Hi everyone, today I would like to talk about the fuzzy logic. So this is the overview of today's talk. So let's see probability and uncertainty. A person suffering from hepatitis shows in 60% of all cases a strong fever. In 45% of all cases, yellowish color skin, and 30% of all cases suffer from nausea. So this is probability or uncertainty. So stochastic and fuzzy logic complement each other. So what is the difference between fuzzy logic and probability? In fuzzy logic, for example, Tom's degree of membership within the set of old people is 0.9. So fuzzy logic takes truth degree as a mathematical basis on the model of the vagueness phenomenon. But in probability, we say there is a 19% chance of Tom is old. Is this correct? So probability is a mathematical model of ignorance. But the fuzzy logic is a membership. If you are, for example, 35 years old, can we say you are old or you are young? So there's a fuzziness to decide it. So we can say might be 80% old or maybe 70% old. So this depends on how you define the membership function of old and young men. So let's see a difference between Cripps value and fuzzy value. So in Cripps value, it has a strict boundary of true and false. Some Cripps times set can be fuzzy. True or false, usually we say 0 and 1. In Cripps logic law of excluded middle and non-contradiction may or may not hold. In fuzzy boundary with a degree of membership. So it can't be Cripps. Membership value on between 0 and 1. So we can have 0.1, we can have 0.05, we can have any value between 0 and 1. So in the fuzzy logic law of excluded middle and non-contradiction hold. Let's compare between classical set and fuzzy set theory. So in classical set, classes of objects with sharp boundaries. A classical set is defined by Cripps value or Cripps boundary. There is a clarity about the location of the set boundaries. So widely used in digital system design. But in fuzzy set theory, classes of objects do not have sharp boundary. A fuzzy set always have ambiguous boundaries. They may be uncertain about the location of the set boundaries. So used only in fuzzy controller. So this example of fuzzy set theory. As a conventional or Boolean set theory, you can see a sharp difference between strong fever and what we call no fever. So there's a clear boundary between this set. But on fuzzy set theory, the boundaries is not clear. So let's say those who have 42 degrees Celsius, do they have a very strong fever? Compared to those who are, let's say, 39.3 degrees Celsius. So for a person who has a temperature 39.3 degrees Celsius, he also has fever, but just a small or what we call lower fever. So we can say more or less rather than either or. Okay, let's have a look on the example of honest. In Boolean logic, if we ask this question, is Nick honest? The answer in Boolean logic is yes or true or false. So either yes or no. But in fuzzy logic, if we ask, is Nick honest? So we can say extremely honest if he always, every time, he never lie to others. So we can say extremely honest. Or we can say very honest, maybe just 1 or 2 times, or maybe 1%, he do not tell the truth. So we can say very honest. Sometimes honest, maybe 50-50, or extremely dishonest. So you can, this is where fuzzy comes through. Because perhaps some people, if in certain situation, he is very honest, but in other situation, he just a little bit not honest. Okay, what is a fuzzy logic and why fuzzy logic? Fuzzy logic is a many value logic from which may have truth value of variables in any real number between 0 and 1. It is the Handel concept of partial truth. So why we use fuzzy logic? In real life, we may come across a situation where we can't decide whether the statement is true or false. Fuzzy logic offers very valuable, flexible for reasoning. For example, the previous example, when we want to mention about whether this people is honest or not honest. So it's hard to say. The fuzzy logic method imitates the way of decision making in human, which consider all the possibilities between digital value true and false. So what is the advantage of fuzzy logic? Mimic human control logic, use imprecise language, inherently robust, fail safely, modify and tweak easily. The disadvantage is operators experience required. That means we need to have a knowledge about the what we call the application so that we can embed the human knowledge into the system to make a decision. Then system complexity. These are some more advantage of fuzzy logic system. The structure of fuzzy logic system is easy and understandable. Fuzzy logic is what you use for commercial and practical purposes. It helps you to control machines and consumer products. It may not offer accurate reasoning, but not only acceptable reason. It may not offer accurate reasoning, but the only acceptable reasoning. It helps you to deal with the uncertainty in engineering. Mostly robust as no precise input is required. It can be programmed to in a situation when feedback sensors stop working. It can easily be modified to improve or alter system performance. Inexpensive sensors can be used, which help you to keep the overall system cost and complexity low. So it provides a most effective solution to complex issues. So what are the disadvantages of fuzzy logic system? It not always accurate. So the results are perceived based on assumption. So it may not be widely accepted. Fuzzy system does not have the capability of machine learning as well as neural network type pattern recognition. Validation and verification of a fuzzy knowledge-based system need expensive testing with hardware. Setting exact fuzzy rule and membership function is a difficult task. Some fuzzy time logic is confused with probability theory and the terms. What are the characteristics of fuzzy logic? First, flexible and easy to implement machine learning technique help you to mimic the logic of human thought. Logic may have two values which represent two possible solutions. highly suitable method for uncertain or approximate reasoning. Fuzzy logic views inference as a process of propagation elastic constraint. Fuzzy logic allow you to build nonlinear function of arbitrary complexity. Fuzzy logic should be built with the complete guidance of expert. So, in building a fuzzy logic system, we need human expert to guide us to design a fuzzy rules. So, when not to use fuzzy logic? If you don't find it convenient to map an input space to an output space, when we cannot relate with input and output, do not use fuzzy logic. Fuzzy logic should not be used when you can use common sense. So, if how you make the decision? If the decision is just made based on the common sense, you have no specific rule, then at this situation, you cannot apply fuzzy logic because fuzzy logic cannot use human sense. Many controllers can do the fine job without the use of fuzzy logic. Okay, application area of fuzzy logic. These are examples from anti-lock breakers. The company is Nissan. So they use fuzzy logic to control the brake in hazardous case depend on the car speed, acceleration, wheel speed, and acceleration. Auto transmission, also in Nissan, fuzzy logic is used to control the fuel injection and ignition based on the total setting, cooling water temperature, RPM, and so forth. So auto engine, Honda, Nissan, for example, used to select gear based on engine load, driving style, and road condition, and so forth. There are many examples of fuzzy logic application in car, photostat machine, washing machine, what we call the microwave oven. There are many. Even in your smartphone, there are a lot of fuzzy logic application. There are 4 components in fuzzy logic architecture. So the first is rules. The rules contain all the rules and the if-then condition offered by the expert to control the decision-making system. Then we have a CRISP input fit into the fuzzifier. So this is to convert the CRISP number into fuzzy set. CRISP input are measured by sensors and passed into the control system for further processing like room temperature, pressure, and so forth. So then the third component is intelligence. To determine the degree of match between fuzzy input and the rules. So based on the percentage match, it determines which rule need to be implemented according to the given input field. After this, the applied rules are combined to develop the control action. And finally, so this step will convert the fuzzy set into CRISP value. So there are many types of technique available, so you need to select each. You need to select it which is best suited with the use with an expert system. So when we output to the environment, we need to convert the fuzzy value to the CRISP value. So why do we need an expert system? The expert system can work 24 hours, but if we ask human expert to work 24 hours, they are very tired, and when they are tired, the accuracy is less. For example, they might get 50% accuracy when they are tired. But for fuzzy expert system, they can work 24 hours with 95% accuracy, for example. Okay. So the non-expert user queries the expert system. This is done by asking a question or by answering a question asked by the expert system. So the inference engine uses the query to search the knowledge base and then provides an answer or some advice to the user. So the knowledge base is fed by the expert domain. So this knowledge is kept in the database system. So this is a fuzzy expert system. We have input, which is a Chris value. We have fuzzifier. We have a knowledge base system to generate the knowledge. So that fuzzy inference will map the input value, the Chris input value, and to control the system and output the defuzzifier and output to the Chris value to control the environment. So this example of fuzzy logic, you review this video. We will have a quiz on this video too. Okay, let's continue with preliminary evaluation. So this is assessment as to whether fuzzy logic is applicable for the given application. So you need to evaluate. These are the evaluation criteria. Has fuzzy logic been previously applied to a similar application with success? Is it a multi-variable type control problem? Do operators and engineers possess knowledge about any relevant interdependencies of the process variables? Can further knowledge about the process behavior be gained by observation or experiment? Is it difficult to obtain a mathematical model from the process? These are some of the questions that you need to assess. If the answer is no, then it is very hard for you to design a fuzzy logic system or fuzzy expert system. So define the control objective and criteria. What am I trying to control? What do I have to do to control the system? What kind of response do I need? What are the possible or probable system failure modes? Determine the input and output relationship. Choose the minimum number of variables for input and the fuzzy logic engine. Use a rule-based structure of fuzzy logic. Break the control problem down into a series of rules. Create a fuzzy logic membership function. Define the meaning of input-output term used in the rules. And finally, test, evaluate, tune, and retest. These are the steps of designing the fuzzy logic expert system. So let's have example of the application of fuzzy logic. Simple proportional temperature controller. So the component is an electric heating element, variable speed cooling fan. So we have heater and we have cooler, that is a cooling fan. The functionality is positive signal output 0 to 100. This is heat. Negative signal output 0 to 100% cooling. So this diagram shows the example of application for simple fuzzy logic control system. CMD is a command or target temperature. So this is the CMD is a target temperature. Then we have a temperature. This is a feedback sensor in a control environment. Let's say you want to control the air conditioner in the your room. So this is TMP is the environment temperature or room temperature. So the fuzzy logic engine will read the input from command CMD, and then it will generate or increase the heater or reduce the cooler, or any either one, depend on the output from the fuzzy logic engine. So this will control the environment temperature. So error is the difference between CMD and the feedback temperature from the sensor. So let's say the command temperature, you want to set, let's say 20 Celsius. And the temperature, the feedback temperature, might be 22, for example. TMP is 22. So you want to set the temperature, the command is 20, but the temperature from the sensor is 22. So what happened is you calculate CMD is 20 minus 22, so you get 20 minus 22, you got negative. So that means the room temperature is still hot. So an error dot. So the error dot is time derivative or error. So positive means getting hotter, negative means getting cooler. So establish the meaningful system for representing the linguistic variable in the rule matrix. So N means negative. So negative arrow dot input level. Z is a 0. Error, 0 error or error dot input level. Positive, heat, H is heat. Dash is no change. C is cool. This is the output. So the usage is define the control objective and criteria. What am I trying to control? What do I have to do to control? What kind of response do I need? What are the possible system failure? So this is the first step. So define the control objective and criteria. What am I trying to control is system temperature. What do I have to do to control the system? Proper balance and control of functional devices. What kind of response do I need? Stable environment temperature. So that means if you want to control the air conditioner, you want to make the controller stable. So when you set the temperature, you can see that the temperature may be reduced, and then it can stable very fast. When you want to set when you want to set your air conditioner to 20 degrees Celsius, for example, so you press the button 20 degree, the air conditioner might not stable yet, so it might cool to perhaps 25. So when the sensor send the feedback to the controller, you can see that the temperature is still the difference between the command and the sensors is -5. So that means you need to set to up the cooler so that it can reduce the room temperature. So this will proceed until the temperature stable at 20 degrees Celsius as what you need to set. If, let's say, one time it dropped to -19, for example, then the fuzzy system will increase a little bit so that it will stable at 20 degrees as what you ask the air conditioner to stay at 20 Celsius. So what are the possible or probably system failure nodes? The lack of the no change region. That means your air conditioner always what we call, sometimes you on the cooler, sometimes you on the heater, sometimes you on cooler, heater. So there is no region that no change. That means your temperature, your room temperature is not stable. You try to reduce the temperature, it's reduced a lot, not to the value that you ask the air conditioner to maintain. So this is what we call no change region. It's not stable. So this is not good for the controller system. I mean your controller is always heat, cool without stop. So we want a good system, stable, very fast, and then until certain time, then it cool again because it can stop the what we call the cooler. So just maintain the balance. This is the condition where the error occurs. So when we try to increase the temperature, it will increase And let's say we want to stable at certain value. So when we increase the temperature, it will increase a little bit higher than what the actual value that the user need. So then we need to reduce. So when we reduce, it might reduce more than what we expected. We expect to reduce. Then we need to increase a little bit, and it will settle down. So we have done the first step. So next step is determine the input and output relationship. So determine the input and output relationship. Define the minimum number of possible input product combination and corresponding output response conclusion. So let's say input 1, we have error, positive P, 0, Z, and negative N. Similarly, input 2, error dot, post P, Z, and N. So the conclusion is output heat is H, and no change is dash, cool is C. So this is the variables that we are going to pass. So input 1, system status, error is a command minus feedback. So this is a CMD minus temperature. So P is too cold, Z is just right, N is too hot. So input 2 is system status, error dot, this is D error divided by DT. So getting hotter, P is getting hotter, Z is not changed, N is getting cooler. So the output is conclusion and system response. So output H, call for heating. If output equals to dash, is don't change anything. If the output is C, call for cooling. So we have done the step 2, and now use the rule-based structure of fuzzy logic. So let's say we set this rule. If CMD minus temperature equals to N, and CMD minus temperature DT, this is error dot, equals to N, then output equals to C. So that means we want to cool down, because CMD is a command. Let's say, for example, CMD is 20, and the temperature is the sensor. The temperature reading by the environment sensor. If CMD, let's say 20 minus TMP, temperature is 25, so we get negative value. That means the room temperature is hot than the command temperature that we request, so you get negative value. And the difference CMD minus temperature, you have negative divide by time. This is also negative, and then the output should be, you want to cool, you want to output, you want to control the cooler, you want to on the cooler again or more. So if you look at here, so error dot, this is command minus temperature divided by DT. If you have the error dot is negative, so the error is CMD minus temperature is also negative, so the output is cool. So the second rule is, if CMD minus temperature is Z, that means no change, and CMD minus temperature divided by DT is also is N, then the output is H. So what does it mean? That the command and the environment temperature is same. So that means the room temperature is stable, same like the command or the request temperature. So you got Z 0. And this one command minus temperature, so you get this one is just a 0. Divide by DT, you get N value, negative. Then the output is H. So you say here DT, you get a negative value, but this one Z, so you put H. That means you want to heat. So if common minus energy is P, positive, and the error dot is N. So if you say error dot is N, and the error is also N, no, sorry, CMD minus temperature, this is P, and CMD minus temperature dt is error dot, so this is N. So you need to activate heater. So this metric will help you to generate the fuzzy rule. How you get this value? This is based on the experience. Since we understand about the temperature control, about the air conditioner, we can directly key in or set the value. But in some cases where the variable is what we call not straightforward, you need to study, you need to do the experiment to set a correct value so that your rule-based structure is correct. So you need a knowledge, you need a theory behind that. So we have done the rule-based. Now create fuzzy logic membership function. So create the fuzzy logic membership function that define the meanings or value of input-output terms used in the rules. So you have a degree of membership, so from 0 to 1. So you have the width, you have shoulder, you have centered here, you have 0 value, you have N and Z, Z and P, and so forth. So now create the fuzzy logic membership function for this temperature controller. So we have degree of membership from 0 to 1. So we have temperature error. This is the temperature error. So you set from -4 to here 0, and then positive to +4. So you draw this membership function, which what we call graph. There are various type of membership function. This is an example of membership function. Later on, the next lecture, we will see how to design a membership function. This is just a simple example about the fuzzy logic membership function. Okay, after you have designed the fuzzy logic membership function, now you need to do test, evaluate, tune, and retest to make sure that your fuzzy logic system work well, work good enough to control the devices. So in a summary, the term fuzzy means things which are not very clear or vague. The term fuzzy logic was first used with 1965 by Ludwig Zadeh, a professor of UC Berkeley in California. Fuzzy logic is a flexible, easy to implement machine learning technique. Fuzzy logic should not be used when you can use common sense. Fuzzy logic architecture has 4 main parts: rule-based, fuzzification, inference engine, and defuzzification. Fuzzy logic takes truth degree as a mathematical basis on the model of the vagueness, while probability is a mathematical model of ignorance. So crypt set has strict boundary T or F, while fuzzy boundary with a degree of membership. A classical set is widely used in digital system design, while fuzzy set used only in fuzzy controller. Auto transmission, fitness management, golf diagnosis system, dishwasher, coffee machines, and some other application area of fuzzy logic. So fuzzy logic help you to control machine and consumer product. So with that, thank you very much for listening and all the best.